Greetings and welcome to the Plsql channel, a series of video trainings on the Oracle Plsql language. My name is Stephen Feuerstein, and I'm a Plsql developer just like you. This lesson is part of my series on writing Dynamic SQL in Oracle Plsql, and this topic is Method 4 Dynamic SQL, just about the most complicated thing you'll ever do in the area of Dynamic SQL. Some quick reminders. Download the code and PowerPoint documents from Plsql Obsession that support this video. So toadworld.com/sf takes you to Plsql Obsession. The demo zip link gives you access to all the files that I'll be running in this lesson and all my other lessons. And if you click on training, seminars, and presentations, you'll find a wide array of my training materials, both specifically for writing Dynamic SQL and more generally for other Plsql activities. So do take advantage of the resources. In addition, make sure you're comfortable with the material covered in the previous lessons in this series, most importantly introduction and overview, understanding the basic concept of Dynamic SQL. Certainly check out executing dynamic DDL, DML queries, and Plsql blocks. These are all the more basic approaches to writing Dynamic SQL, and they generally involve using execute immediate or native Dynamic SQL. This topic, Method 4 Dynamic SQL, is among the most complicated you'll encounter, and it doesn't rely on execute immediate, or generally will not. So, Method 4 Dynamic SQL, what the heck is that? So Method 4 is the most dynamic and most complex. There are two basic possible scenarios. Number one, at the time you compile your code, you don't know how many expressions will be in the select list of your query. So in other words, you might be selecting 2 columns, 25 columns. You just don't know at the time you're writing your code, which essentially means you need a dynamic into clause. Second, at the time of compilation, you don't know how many placeholders will appear in your string. :ABC, :DEF, every placeholder needs to have a variable bound into it so that you can either send values into the string or retrieve values from the string. So in this case, you need the dynamic using clause. But execute immediate, native Dynamic SQL's major statement for executing Dynamic SQL statements, has into and using clauses that are not dynamic, they're static. At the time you write your code, you have to specify how many elements you're either fetching into or binding into or fetching out of the string. So in general, when I have either one of these scenarios, I don't know how many things I'm selecting, I don't know how many things I'm binding in, you can't use execute immediate, and we need to take a look at using something else. And that something else is the DBMS SQL package. It's probably one of the biggest, most complicated packages, and that's why for all the other forms, methods 1 through 3, Dynamic PLSQL, execute immediate is definitely the choice that you want to take, the approach you want to take. But it does too much for us, and it does it implicitly. So we have open cursor, it binds our variables with the using clause, it executes the SQL statement, it retrieves the values into, it closes the cursor. It simply does too much because we need more control over these different operations. For example, how many things are we binding? How many values are we retrieving? We don't know this at compile time. So basically, we can't use execute immediate, and we need to switch gears and learn about and use DBMS SQL. Now, this lesson is not going to provide you with a detailed training on every element, every aspect of DBMS SQL. This is a package you're going to run into quite rarely and only really for this one purpose. So I'm going to focus on several different examples that demonstrate the kind of code you'll need to write for DBMS SQL Method 4. And here I'll give you a quick guide to the most important subprograms to know about. But there are many, many more. You can certainly check out the Oracle documentation or my book, Oracle Built-in Packages, which covers DBMS SQL in depth. So before you can do anything with DBMS SQL, you have to open cursor. You have to call the open cursor function to allocate a handle to a cursor. And a DBMS SQL cursor is an integer pointer essentially to a set of data. Define column is used to define an individual column in your dynamic query. Even though Oracle is parsing the SQL statement and therefore it can understand how many elements are in the list, you still have to define the data type of each column. Next, you're going to parse the statement so you can make sure that your SQL statement is valid. And bind variable, if you need to bind a variable to a placeholder, you'll call the bind variable program. You execute the statement, fetch one or more rows, retrieve the column value, so I fetched a row, now I get my individual values. And whoops, though I didn't put it here, sorry, there's also a close cursor. Close the cursor when you're done. I should add that in there. Sorry about that. So these are just a small part of the many subprograms in DBMS SQL. Like I say, it's quite complex. You can do an awful lot with it. But the main thing is to make sure you understand these basic steps involved for method 4. And what I'm going to do is basically run through some examples. And the first one I'm going to show you is a dynamic select star from table, essentially doing the same thing that you would do with a select star from table in SQL Plus. Show me the contents of your table, doing it in Plsql instead. Which means you provide the table name, you can provide a where clause, the schema name, and I'll display all the data in that table. Obviously, I don't know in advance which or how many columns will appear in my list. So this is an example of method 4, Dynamic SQL. Give me any table you want, I'll retrieve the data, and I'll show it to you. So the question then becomes, in general, with Dynamic SQL method 4, how do I know how many columns I've got and what their types are? In this case, it's a relatively simple case. I can obtain the column information from all tab columns, a data dictionary view that contains the information about columns in a specified table. Another approach you can take is to use describe columns in DBMS SQL, which is covered in the separate advanced features lesson. So check that out. If you don't have access to the individual columns in your list, and you don't have something like all tab columns to retrieve the data from, that'll be an alternative. This is also, because I can get my columns from all tab columns, it's a relatively simple example to use as a starting point. So let's walk through the basic pseudocode flow, the basic steps you have to run through with DBMS SQL. Then we'll take a look at the code. But actually first, why don't I show you the program in action? So it's called the in-tab procedure. Let's pull it up. So in-tab, pass in the table name, pass in the where clause, pass in a filter on the columns. So I can say we'll only retrieve the columns that have the phrase _ID in it. Let's compile this program and let's try it out. Well, I'm going to do something simpler than all of this. I'm just going to say, for example, show me departments. I'm going to grab this code and I'm going to run it in SQL Plus because it's a lot easier to see the formatting. So let's run this block of code. And notice, there's all the data in my departments table, nicely lined up. I'm really impressed by how I got everything to line up. That's actually the hardest part of the program I'm going to show you, and I'm not going to focus on that. We'll focus on the Dynamic SQL part of it. So there's all the data in the departments table, and I could change this to another name, like locations. And I run this code. And now we see the locations. Clearly, different table, different columns. My program is able to figure out which columns there are, how many columns there are, and then display the information. So this is an example of Dynamic SQL method 4. Okay, so let's go back to the overview, the flow, and then we'll take a look at the code in more detail. So here are the basic steps I have to go through. First of all, I have to construct my SQL statement so I can parse it. So basically for every column in my table, I'm going to add the column to a select list. I'm going to build A, B, C, D, add the where clause as necessary. Then I'll parse the statement for the cursor that I've opened for that select string. And DBMS SQL native basically says use the native features of the language, the current version. Then I have to define each column before I can execute. So I've parsed it. It's a valid SQL statement. But before I execute, I actually have to tell Oracle what my columns are, how many there are, and what their data type is. Then I can execute the query. And all that does is essentially identify the rows and columns, the set that I'm going to retrieve for this query. Then inside a loop, I'm going to fetch the next row And while I'm not done, for every column in my table, I'm going to call column value to retrieve the value at that location. So as you can see, lots and lots of detail, many steps, but this is exactly the level of detail I need. Since I don't know how many columns I've got in advance, I need to call define column in a loop. Since I don't know how many columns I have in advance, I need to fetch the column values one by one inside a loop. There's no way to do this with execute immediate, but I certainly can do it with DBMS SQL. So here's a case where the complexity of DBMS SQL, which usually works against the value of using the package and is the reason that Oracle introduced execute immediate, that very complexity is exactly what we need and what is welcomed for method 4 Dynamic SQL. So let's take a look. It's a fairly large program, over 400 lines. I'm obviously not going to go through every detail of this, but as I mentioned earlier, a lot of the code here has to do with formatting the columns, figuring out how wide each column should be, and then formatting the results. That's not particularly of interest for you from a method 4 standpoint, so I'm not going to go into the details on that part, though you're certainly welcome to explore all the details over and over again. So, out of my 400 plus lines of code, notice that my main body of code is just 5 lines long. It's essentially a table of contents. And I accomplish this by using local subprograms. So each of these programs are defined inside my main program and allows me to hide the details and make it really easy to understand and read this code. So first I'm going to load the column information. Next I'm going to construct the query and then parse it. After that, it's time to define my columns and execute my statement. Then I'm going to build and display my output, which has to do with fetching the rows and then retrieving the column values. And finally, I'll do my cleanup. So let's go through these. So here's my cursor. It's an integer, and I simply call DBMS SQL open cursor to allocate that handle for me. And that basically says this is my results, that this is my SQL area for this particular operation. And I always reference n equal to DBMS SQL includes this cursor, so DBMS SQL knows which cursor, which result set I'm working with. Then as you can see, there's lots to do with formatting, lengths of things, figuring out which type it is. You have to know which type of data your different columns are. And basically what I'm going to do is just check for strings, numbers, and dates for a variety of data types. Clearly this is not a complete implementation, and it's very hard to do really complete implementations for any type of data, any number of elements, and so on. Okay, so I need to load my column information. Again, this is the part where it's highly varied based on your requirements and what information is available to you. Since I'm specifying the table, or the user is specifying the table, I can reference the table and check for that column filter list, of course, and get all the columns for that table. And I'm going to bulk collect them, retrieve them quickly into my array of column information. So gcolumns is defined as a list of all tab columns rows. So that basically lets me dump out the column information. Again, if you're not using something or don't have access to something like all tab columns to get your column information, you're likely going to be using DBMS SQL.describe columns, which is covered in advanced features. Okay, so I've got my columns. And then I'm going to run a bunch of code to calculate the size of my columns. But most importantly, so here's my loop through my different columns. Most importantly, what I'm going to do is build my select list. So add comma and then the column name over and over and over again to build my select list. And then I'm going to construct and parse my query. So I'm going to add a where clause. If somebody's provided a where clause string, if it's not null, then I'm going to put this information onto in my where clause variable. And note, this could lead to problems regarding SQL injection. This is covered